Yay! Woohoo!
Welcome grade 12s, and in this video we'll be discussing on how to derive the arithmetic and geometric series equations. So we'll start off with the arithmetic series equation. So we know that the equation looks like this: plus n minus 1 d. So now the question is, how do you get to this equation? Well, we have to know this information because it could be asked in an exam. And if you and I do not know it, then we would have lost about 4 to 5 marks if we're given this question. So now they could say, show that the sum of an arithmetic series could be given by this equation right here. Okay, so now what we're going to do is we're going to develop two equations. Let me just use the blue pen here. So we're going to say Sn is equals to A plus A, not AR. That would be geometric. A plus D plus, and let me just put them in brackets like that, A plus 2D and A plus dot, dot, dot. Let me just go to the end there, which would be A plus n minus 1 D, like that. Okay, so now this would be our first equation right here. And as I said, we're going to develop two equations, right? So we're going to take the same equation, but now in this case, we're going to start off with this last term and end with A. So now let's just say that this was a growing progression. This means that we were going to start off, the first equation is made up of ascending order values, and then the second equation would be made of descending order values, right? So here we'll have Sn is equals to, then as I said, we're going to start off with the last term here, so which is going to be A plus n minus 1 D plus, now the second term here could be A plus n minus 2D, then plus dot dot, then we're going to go on to, maybe let's just say A plus 2D, and let's just have maybe here A plus D plus A, like that, right? Okay, so now here maybe I could remove this one, but it's okay. So now you have equation 1. Let's just label this as equation 1, and we're going to label this one as equation 2, like that, right? Usually we put them down here. We say 1, and we call this one 2, right? So now what you're going to do from here, you have developed these two equations, one in ascending order, as we're saying, and one in descending order, right? Or we're just reversing the patterns like that. So what we're going to do now is we're going to add these two equations, right? So we're going to say 1 plus 2. Okay, so now looking at this side here, the left-hand side, we're going to have 2Sn, because that would be Sn plus Sn. That's going to give us 2Sn. And then right here, we're going to align the terms such that this term A is added to this first term A right here, okay, on the descending one. And then this second term corresponds to that second term right there. And the third term could have corresponded to some term right here, and going on so forth. And the last term right here is going to correspond with the last term right there, which is going to be A. Okay, so now here you have A plus this part here, which is going to give us 2A plus n minus 1 D. So this part right here is straightforward because you're just adding A to this A right here, and you're going to keep this part. Okay, and now let's look at the second part here. When I'm adding this guy right here, A plus D, to this value right here, we want to know what's going to happen right here, right? So you have A and A there, so you're going to get, so let me just say plus, because it's a plus still in between, we're going to have 2A, right? Now, we're wondering this value of D and this part right here, what is it going to simplify to? Well, we can find out. We're going to say A plus D, and we're going to, I'm just going to break down this value here. So it's A plus, this is going to be Dn minus 2D, like that, right? So A plus A, it gave us that 2A that we have there. Then right here, we're still going to have our Dn, because there's no other term that can add with Dn or subtract with Dn. And here we have a plus D minus D, so that's going to give us a minus D right there. So now if I then factorize the value of D again here, then we're going to be left with 2A plus n minus 1 D, like that. So you see that this term here repeats itself, n minus 1 D, like that. Plus, and this is going to be true going forward. So it means that this term A plus 2D and this value right here, this would have been a plus n minus 3 into d, right? And again, you have 2d, then here you would have minus 3d. That's going to simplify to a single minus 1d, right? So meaning that the terms here, when you add them together, the green, the purple, and anything else that follows here are going to be the same value. So this means that up until at the end right there, so it means that we are going to still have 2a plus n minus 1d. So you'll be having a value that repeats itself, as you can see, up until n here, up until n times. Depending on the number of terms you will be adding together, right? So let me just remove this part right here. Okay. So now the question is, how many times is this repeating itself? Well, since we are adding n terms, so it means that this repeated addition is repeating itself n number of times. Okay. So if maybe someone does not understand, let me just make an example here. Okay. So now let's say I have 5 plus 5 plus 5 plus 5 plus 5 plus 5 plus, let me just add another 5 there, right? So now here, what you have, this is repeated addition, right? Repeated addition turns into multiplication. Okay, so how many 5s are you adding together here? So it's 1, 2, 3, 4, 5, 6, 7. So now it means that I can factorize the 5, right? Then now in there, what am I going to have? It's 1 plus 1 plus 1 plus 1. So how many ones? 1, 2, 3, 4, 5, 6, 7. So I have 7 ones. Now you add up all these 7 ones, you're going to get what? 7. So this is going to be the same as 5 multiplied by what? By 7 right here. So this means that you have 5 repeating itself 7 times. So now hence we said that repeated addition turns into what? Into multiplication. So now this has the same effect. This 5 times 7 here, which is going to give us that 35. It means that this value here is going to be 35 as well. Okay. So now here, let's bring it back to what we have here. Let's bring it back to what we have here. We have these values that are adding together, right? Same value repeating itself n times. Why are we saying n times? Because we are adding up until n terms. Okay. So now there were n terms here. Then we're adding together those corresponding values. So it means that we still have n terms at the end, right? So now that repeated addition can be now changed into what? To multiplication. So what are we going to have here? We're going to have this value. Let's factorize maybe this value here. So I can factorize n, can write n first, so that it is in keeping with the equation here. So we're saying that n multiplied by what? Multiplied by this value right here, n minus 1d. So if you don't understand, remember that this 2a is repeating n times, right? So I'm adding the same value n amount of times. So that can be written as n multiplied by this value. Same as that 5, which was added to itself 7 times, that could be written as 5 multiplied by 7. Okay, and then on this side here, we still have our 2Sn. And now remember, we are looking for the value of Sn. We're going to divide both sides by 2, divide this side by 2. Then you're going to have Sn is equals to n over 2 into 2a plus n minus 1 d, like that. Right. Sometimes you'd see that in some books, you'll see that they will just have that and say this repeats itself n number of times. You can indicate that it's fine, but then, well, we could assume that it is understood that it repeats itself n times because you are adding n number of terms, right? And that would be the end of the proof right here for the arithmetic series. Okay, so let's move on to the second part of things, which is going to be your geometric series, right? So this is number 2. Okay, so with the geometric series, we know that we have 2 equations, which is Sn is equals to a into r exponent n minus 1 over r minus 1, or you could have Sn is equals to a into 1 minus r to exponent n 1 minus r, like that. Okay, so the proof for both of these is going to be similar. It's just a small change, right? If you want to get the first one, you're going to do something. If you want to get the second one, you're going to do, but the changes are slight, they're small, right? So it means that when you know this one, the proof for this guy right here, you're definitely going to know the proof for this one right there. Okay, so as we did with the arithmetic series equation, we're going to develop two equations as well. Okay, so the first one here for Sn, we know it's a plus ar plus ar squared plus da. Let's just take it up until ar n minus 1, like that. Okay, so and this guy right here is going to be our equation 1. Okay, now we're going to formulate equation 2 by multiplying both sides of equation 1 by r. Okay, so now when you multiply both sides by r here, this is what's going to happen. We're going to have r multiplied by Sn, and this first term right here, a multiplied by r, is going to give us ar, plus now a multiplied by ar, right? Or multiplying another r here, this is going to give us ar squared, because there are two r's now, right? Remember, when you like multiply two terms or like terms, you add the exponents. So you're going to have ar multiplied by r, then you're going to have two r's in there, hence it's going to be r squared. And this is going to continue like that. This is going to be r cubed because you're adding an r, right? Plus da. And when you get to this point right here, it's going to be ar exponent n. Okay, so now what happened to the minus 1 right there? Let me just do it for someone's sake. So it's ar n minus 1 multiplied by r. Then this means that you have ar to the exponent n times ar minus 1 times ar to the power 1 to the exponent 1. Now these two guys right here, right? It's minus 1 plus 1. Remember that when you multiply two terms that are the same, right? You're going to add the exponents. So minus 1 plus 1, that's going to give us 0. Now r to the exponent 0, that's going to give us 1. 1 multiplied by the remaining term here, you're going to be left with ar to the exponent n, like that. So that's why it simplifies to that. Okay. So now this means that we are going to have our equation 2 after multiplying by r. Okay. Maybe I could add this part right here. You see right there, you have ar n minus 2, like that, right? Before this one. So this means that this guy here, when you multiply by r for here, it's going to be ar n minus 1. Okay, so that's what we can think of there, or that's what we should know. Maybe let me just write them in. Because someone might not see where we're coming from with those values right there. So dot, so it's plus ar minus 2 plus ar n minus 1. Okay, and this guy right here, when you multiply by r, it's going to be minus 1 plus, and when you multiply the last term by r, that's when you're going to get ar to the exponent n, and we're going to call this guy equation 2, right? Now from here, well, since I'm trying to focus on the first one right here, which is this one, then you'll see that the slight change can produce equation, this second one right here. So what are we going to do here? Now we're going to say equation 2 minus equation 1. Equation 2 minus equation 1 produces this guy right here. Let's call this one A, and let's call this one B, right? So now it means that if I say equation 2 minus equation 1, I'm going to produce A. Then if we say equation 1 minus equation 2, then that's going to produce B right there. Okay, so let's continue with that. So now here I have r Sn minus Sn. So we have r Sn minus Sn is equal to, right? Then now you see that what you're going to get is, remember you are saying equation 2 minus equation 1. Okay, so this guy right here, this ar is going to subtract this ar here, right? Well, there's no term that can remove this a, so we're left with a minus a. Remember, equation 2 minus equation 1. So it means that there's a 0 here, minus a. So we're going to get minus a, right? And in ar minus ar, this removes that, this removes something in there, and it goes on like that, right? So it means that this is going to remove something in there, this is going to remove that. And now we are going to be left with this term. Remember that this term is the one that's positive, and the a is going to be the one that's negative. So this is what you're going to be left with after the subtraction. You're going to have arn minus a, like that, okay? Then now what you can do is factorize the common factors on both sides. So you're going to have Sn, then you have r minus 1, and this side you're going to have ar to the exponent 1, n minus 1. Then divide both sides by r minus 1, r minus 1. And then now you have it as n is equals to a, which is exponent n r minus 1, like that. Okay, and now this is going to be the proof for A. Okay, and then as I said, if you're looking for the proof for B here, we're going to have a slight change where it's which equation minuses the other here. So we know that for us to produce B here, we're going to say equation 1 minus equation 2. Okay, so now this means that we're going to have Sn minus R Sn, and now you're going to reverse the roles here. It's going to be A from the top here minus AR to the exponent n. Then again, factorize the common factors on both sides. Then we're going to have Sn into 1 minus R. This side is A, so 1 minus R to the exponent n. And as you can see, it's going to give the equation of 2 there. So we're going to have A into 1 minus R to the exponent n over 1 minus R. And this produces B. So these are the slight differences that you're going to have there. And these are the two equations or the two derivatives of the arithmetic and geometric. The next time I see you, surely we'll be doing questions. Cheers. See you on the next one.